All right, welcome everybody. I'm Lucian Fogoras, and today we're talking about energy transition. Our guest is Mr. or Dr. Colin Parris, Digital's Senior Vice President, Chief Technical Officer. First off, congrats on being elected to the National Academy of Engineering, and thanks for joining.
Lucian, it's my pleasure. Thank you very much for having me. It's an honor to be here.
Honors on our side, and maybe we'll start with that. What exactly is this National Academy of Engineering, and how does one get nominated? If you don't mind explaining, just briefly expand on that.
Well, maybe we'll see if my explanation sort of makes sense. So, what the National Academy of Engineering was commissioned by Congress, a few decades ago, and what the purpose of it was to actually give the government the ability to understand technology trends that were emerging and find ways to help the US government position themselves and the economies and businesses we support as leadership around the world. It started many years ago in terms of, construction, all the bridges that were being built and infrastructures in the early years after the 1930s and 40s, they needed support. Then it moved off into helping things with the atomic issues that you had, and then into communications. So it's been expanding. It's roughly about 2,000, a little over 2,000 people. In terms of getting nominated, the real answer is, I don't know. So you are not allowed to select yourself. You are selected by the actual members of, the academy. They look at scientists themselves that they believe are contributing or going in the direction we need to go in terms of the US and in the world. And as a result of that, they evaluate you. They look at all your past work. It takes a year or two, and then they would just reach out to you and actually tell you if you've won. Now, again, from what I find out right now, you can go forward 2 or 3 years. Every 2 years in a row, they may look at you again if you don't get in the first or second time, but you never know. So it's entirely done internally, and it shows up as an honor, and to me, it was a stunning honor. And in fact, I should say, I don't think the honor really is mine alone. It's just a way of saying that I've been on great teams with great people over the course of I've been doing this 35 years, and as luck would have it, some brilliant work has occurred because of the team, and I get to reflect that. So, I accept the honor on behalf of the team and everybody who's worked with me and helped me. So, that's it at a high level.
Thank you for that. And I know your background includes IBM, includes General Electric in key positions, and now supporting the government in the energy transition. I think that's great. Maybe we could start with just maybe how does digital twins accelerate the energy transition?
Yes, that's a great question. So for me to answer that, let me step back and give you some foundational information, because here's where it gets interesting. So when we think about the energy transition, it's all about the grid, right? The grid is a way that energy is generated, usually with fossil fuels. It's transmitted across many lines because all of the generators are far away. Then it's distributed to homes, to factories, right? And then it's consumed. It's consumed in the factories, it's consumed in the home. And so that's an ecosystem that when you combine it with the motion of electrons, you call that a grid, right? And the great thing about the grid has been that is what is viewed as the most marvelous machine humanity has ever created, because it touches everything in the world and it becomes the basis of our society. Right, skyscrapers. If you go back to the early days of General Electric with Thomas Edison, the reason why you can have a skyscraper, two things. One was most people couldn't walk above 5 flights. So with the elevators, which are run by electricity, reason you can get lights all the way up and not be darkened when these tall buildings show up is electricity. The reason for advancement in anything, if it be medicine, if it be communications, it's all electricity. It's the foundation of our society right now as we know it, right? At least advancement. So now what you had before was a stable sense of generation. I would buy fuel, use that in a gas turbine or steam turbine, generate electricity. And then every house usually consumed roughly the same amount of electricity based upon the size of the house, right? Square footage, same amount. That was the world as it was. And then you figured out how to create the grid stable. Now, here's the brilliant thing about electricity. If I walk in my house and I turn on the lights, I'm not surprised. I don't clap. If I flick the switch and the lights don't come on, I am pissed. It has become such a part of the fabric of society that you got to have it. So now imagine that world where you depend on this, it changes our society, there's a stability, everything is known. How much you generate, how much you consume. Then you say, you need to decarbonize in order to save the planet. We need to reduce the amount of carbon. And so what will be the new fuel? Because fossil fuels generate a significant amount of carbon. Well, the new fuel is going to be a fuel that's free. It's going to be sun and wind. And you say, great, we can use that. That's free fuel that literally gives you no carbon. Here's the problem. The fuel is variable. The wind blows. Now, most people don't know this, but a wind turbine is roughly 200 feet up in the air and then another 100 feet, for the blade itself. So that's 300 feet, roughly 30 stories. The wind speed is different every 5 to 10 meters you go up. Where you put that wind turbine, if you move it half a mile, the wind speed is different. The wind speed changes every hour. The wind speed changes every week. It changes every season. It changes with extreme weather. We think we know the wind in Europe. Normally we know in summer the wind dies down for a week and 10 days. Last summer, it went down for 3 weeks. It's totally unknown. You have a fuel source that you don't control, that's unknown. Then now, so therefore generation now becomes, wow, it's really uncertain. Now consumption. Normally, every house consumes a certain amount of energy. Great. But now we've put solar panels on the house. And so some days when it's sunny, the house consumes a lot less. Some days when it's cloudy, it consumes a lot more. Electric cars. Now we knew that if you have a car uses petrol, it never affects it. But if you bring an electric car, it suddenly affects the household. Wind farms affect society. So now the demand is changing in the load. So what you have is an infrastructure that was built that was constrained. We knew the assets. We built them 60 years ago. They're aging now, but it's the same assets. We have the same processes. We have the same requirements from government in a dynamic world where the generation now is changing because of wind all the time and solar. The load is changing. At the same time, you have weather events that are extreme. We had one in the last 40 years from 1980 to 2020, $1.87 billion worth of damage through weather events. The last 5 years, 600 billion because of extreme weather. So the weather is changing. The government regulations are changing. Cyber attacks could change it. So you have a very dynamic world, and it's all running on some very constrained, stable assets. So the only way to solve that, with everything changing, and at the same time, humans want stability in the energy. They want the same cheap price. They would like to make it reliable when things occur. They want to make sure carbon is low. So with all those changes on an old, very, very stable infrastructure that can't change quickly, how do you achieve all of this? And that's the energy transition as we attempt to save the planet. So the only way you can deal with the level of dynamics in this constrained environment with all the variables is through software and through AI. And so we built this thing called a digital twin. A digital twin is a model. Everybody knows models. They use models to do everything, but this is a living learning model. What do I mean by that? Living model. So the model is constantly updated. Every time something changes, we look at the model reevaluates itself. Learning. If there's a grid in the US and there's a grid in Europe, and the grid in the Europe experiences certain dramatic weather changes, why can't I take the learnings in that model and bring them in to the current US model, right? So now the model gets smarter. A living learning model is the twin. And what it's used for? It's used to plan. How do I build these things? How do I add new renewable wind farms and solar farms? How do I add all these vehicles? Then how do I operate in normal conditions? Can I get early warnings of failure? Can I predict what may happen? Then how do I operate in extreme conditions, extreme weather, extreme cyber attacks? So that was a long discussion, but the net of it is that the grid is becoming so dynamic that you need this living learning model to help us humans understand what to do in order to give you that stable electricity with low carbon and affordable. Let me stop there, Lucian. Make sense?
Thank you for a great background there, that because good foundation, and also keeping on the same layman's terms, maybe what challenges have you faced in building your organization as you build this digital twin to support the energy transition?
Well, if I think about it, I think there's three problems. The first problems are the processes, right? So what happens is that people in these large utilities, what they tend to do is they say, let's build a process by which we're going to deal with a problem. And that process is built over decades, and nobody wants to change it because it works well, except when things change, you've got to change the process. So we find there's a lot of challenges where people say, well, I normally handle a weather event this way, but because they're having so many weather events and wildfires, you got to find a different way. And it's always hard to change a process. First problem. So process and culture. Second problem is you need data. I need to understand, for instance, this is the weather event. Can I understand the impact of that weather event on my aging infrastructure? What would the wind speeds be in the weather? How would they hit these large transmission poles I have? Would that cause vibrations for it to break? Right? So I need more data on how, the age of the infrastructure. How close is the vegetation to these large lines? So much more data is needed. And then the third thing that you've got to do is you've got to find a way now to take that data and transform the process so you could include the interesting data that gives you insights into the new process, and now you're able to actually withstand it. So three things: the process, the data, and that integration of the two. Those are the biggest challenges we have.
Got it. And if you could go back in time, what else? What would you do differently in this process to address the process, the data, and the insights that you get from those data?
Yeah, initially my biggest failure was I thought this was a technology problem. If I give you the right technology, guess what? You know, I can give you insights into what's going to happen. You take the technology, you use it. I was very wrong, because, for instance, if you have a process in which 5 of you get together in a room and you say, well, last year it looked like this, and so we should do this year. If that's your process, then how do you insert new data in that process? You know, so I forgot about the fact that we need to change the process and the culture. People have got to believe that these twins and this AI and this analytics could help you. And so now I would go back and I would spend a lot more time on the process itself and where value is created, and how to integrate the human and the new data coming in and the new digital twins into the process, and change that culture. First thing I do. Second is the data. We have a lot of data and we quickly find out the data is wrong. You know, well, what happens is that, you know, people write things down on pieces of paper. They transcribed a different meter number. The wind speed was 14.6%. They wrote it down as 146. You know, you have all these challenges around the data. And then what we do is we collect the data, but we never use it. And what happens if you just collect data without using it? You don't even know you have mistakes in that. So when you go back to use that data, and you said, I collected all this wind speed data, you found out that maybe 2 sensors out of the 8 weren't reading properly. So you have all the wrong data. So we have challenges around people and processes. We have challenges around data. And the third thing we have challenges around is the speed at which we do things. The grid has been stable for so many years. And so when you try to introduce speed now, people say, no, it took us 10 years to put up the equipment, 5 years to validate it. That's what we have to do. But the storms are increasing in frequency. The changes are increasing. So I would have started with greater urgency. Right. So those are the three things that are done differently.
Thanks for sharing that. And one of the thoughts came to my mind as you are going through this, and certainly large companies can afford it. Is there anything that GE is doing towards democratize the digital twin as folks are moving towards microgrids, as we're moving towards smaller, having panels everywhere? Are there things that you're putting into the hands of a startup, for instance?
Yeah, well, we're doing two things, right? One is the notion that we have a lot of information on the transmission and the distribution grid, but what you're looking at now is there are new things coming up at the what we call behind the meter, the edge of the network, microgrids coming up at the edge of the network, you know, virtual power plants coming up at the edge of the network. What we're doing is we're working with teams to integrate that data into the distributed system, because then the system could say, all right, in an extreme weather events, what things do I shut down? Or maybe because you have a nice battery, you could actually, you know, give me energy to help the rest of the grid, to stabilize it with inertia. So we're spending a lot of time creating these interfaces, and we're spending a lot of time actually in consortiums where we're working with some of the younger, you know, companies that are really nimble and that are dealing with some of these extreme, you know, situations a lot quicker. So I would say it would be three things. One, it was interfaces by which you can put that data in, consortiums and partnerships in which we're working with the young teams to bring them in. Also government agencies, the Department of Energy, the Department of Defense, DARPA, has a lot of funding it's pushing right now to address these problems. And so what we do then is we write proposals with universities and with small startups in which we can go after getting that funds. And it allows the startup to join us with GE, who has the experience and access to customers, and the university with some brilliant different thinkers to all come together. And these are the ways, because you have to do collaborative innovation now for us to solve these problems.
Right. Growing that the partnership ecosystems is key right now, sounds like.
Yeah.
So I want to switch just a little bit about something that's it's key to us as well as IoT world. As we've grown this community to 300,000 people. What's your favorite debate about the connected industry? Is there something that you feel strongly about that may be different from the common practices, beliefs in the IoT realm?
Well, I don't know if it's common practices, but I worry about the performance. The reason why I love the work that IoT does is because the biggest issue we have now is how to get the data. There's something I think of as gold data, right? We got data before based upon either it was important to the infrastructure we had, which was stable, but now that the infrastructure is changing, well, I mean, we didn't think about that before, so we never got that data. So in the IoT world, there's a lot of new sensors being created. Those sensors collect data that we need now that's vital, right? So that linkage is astounding for me. The other thing is, in many cases, the analytic, we would collect all the data at the top, and then we'd say, okay, now let's churn that data, let's make a decision, send it back down. That's too much data and takes too long. If I have these very, very smart IoT devices that are the endpoints, those devices could actually look at the data there, make quick adjustments for things like the inertia, which is when the frequency changes in the grid, or they could make quick assessments of the fact that one of these substations looks like it's having a problem. Here's an anomaly. So because you're getting these smart devices that can collect the right data, which I call gold data, they can take the right actions because they have the processing power and the ability to do those actions. That gives us a freedom and a power that's very, very interesting. So this is the discussion of how powerful, in terms of connection, can you distribute the capability? So there's always arguments that say, no, it has to be centralized. One person has to orchestrate everything. But that's not possible right now. Given the speed of response, given the fact that people are putting new things at different places in the network, it has to be distributed. So one argument that always shows up is that, should we go all centralized for control? Should we go all distributed? Well, we have to have a grid. So parts will be centralized, but we have to go distributed. Thank goodness the IoT thing works. The second one is really identifying, the problems. Many people think they understand the nature of the problem in the ecosystem because the notion is, well, you have a grid, just generation connected to transmission, distribution, and consumption. Yeah, that's one ecosystem, but overlaid on that, you have a market system by which you buy the power a day ahead, long-term power plants 10 years ahead, 5 minutes ahead. That market system overlays on top of that. Those have to interact. Then you have a government regulation system. Who can buy, who can deliver power, that has to interact with the ecosystem below. Then you have a consumer ecosystem. Some people are saying, I'll never want that kind of power in my house. And they are pushing, different mandates. All of these things have to be connected. We think it's a technology and interconnection problem. No, it's not, because right now we're seeing in parts of Europe where people need to run these long distance lines so that they can go from offshore wind turbines all the way to bring in new electricity. And people are saying, I don't want to run it through my farm. Why? I think those transmission lines, whether it be above ground or underground, actually, create health concerns. So when you thought this ecosystem was all about just tying the technology together and the governments together, the people are blocking you. So you have to look at the entire ecosystem. You have to bring all of them together, right? Because they all have to have a say. You've got to tie it to jobs. You've got to tie it to safety. And I think that's the other argument that's going on right now that I have a different point of view on. Plus, I'll tell you one last thing as well. We have the carbon discussion going on, and the large countries say things like, well, we got to reduce, the carbon footprint. But when you go to the developing countries who are much more interested in just simply, bringing their, people in poverty to low and middle class, they're saying, well, if I give up all of the cheap, coal and the cheap fossil fuel, I can't give up that because then my population dwindles. They can't feed themselves. And you're telling me I need to do that, or else, I'm a bad contributor when most of the, fossil and the emissions of carbon came from the developed world. So we have to find a way to have that discussion, because it will end up being about the people. Because people will take, if your child is dying or if your population is dying, you will go and take an extreme point of view, antagonistic to everyone, because you've got to deal with that immediate issue.
Yeah, I fully agree with that. I did a trip to Egypt, and we're going to visit a large power plant that was a gas turbine, and gas turbines were getting purged out of Europe at that particular time. And I'm thinking, what did I get myself into it to get associated with a brand that's doing that in Egypt? And I got there, there's like 50 minutes worth of dry and piles of garbage on the side of the highway. And then there is this, if you will, 10% of the population still with no electricity. I think these people have different problem than having a little pollution from the gas turbine in some parts of the world. So there's that aspect of that.
Exactly. Lucian, let me say one thing to that too, because there's the other thing most people don't realize. If you have to actually do any smeltering to get iron and copper and steel, enormous energy, 3% of the world's energy, that can't be wind. Because again, this thing has to be, remember, all of this stuff is molten liquid that you're pulling out impurities. If at any time this shuts down, this thing solidifies in an hour, every pipe burst. So smelters, fertilizers, concrete, the very fabric by which we live, because the fertilizers of our food, the concrete is how we build buildings. All of these need massive forms of power, and renewables can't fulfill that right now unless you over-deliver, and you're not going to over-deliver because nobody could afford that. So I think we've got to look at this thing as a real systemic problem on the planet right now and fix it.
Yeah, I fully agree. Thank you for that. You've mentioned a couple of things in terms of process transformation plus digital transformation. I think your team refers to Lean+Digital.
Yes.
Do you want to expand as the last question? What are some of the benefits, concrete benefits that GE Digital and its customer have seen from the implementation of Lean+Digital?
So what we did is, the Lean+Digital, Lean is a technique by which you look at a process and you do a value stream map. Where is value in your process? Where is waste in your process? Take out the waste, right? Enhance the value. At the same time, you'd use data to make those decisions. Well, that was perfect for me. I'm a data scientist. If I can get that data and I can actually show you through analytics, this is a problem, this is an optimal way to do it. I can predict things. That combination of process transformation by Lean and inclusion of data, that gives you the best of both worlds. It removes waste and generates better results. So we see it in two ways. One is we look at productivity. We have customers in which we service their turbines, right? Now, can I change that process and use digital twins to tell me what's wrong with your process before I get there? What's wrong with your turbine, right? What part is being damaged, rather than just opening it? And so now what I can do is I can show up with the right people and the right parts, so that when I go in, I do that a lot quicker and a lot lower costs. That's productivity on the services side. The other angle of this is when you actually are trying to figure out with on the revenue generation side with customers themselves are trying to figure out, how should I run my turbine so that when I literally need to have that turbine have the ability to overfire, in other words, to generate more electricity because it's a very hot day? Usually customers are worried about that, because if you overfire the turbine, if you actually turn up the temperature to deliver more electricity, the parts burn up. That's what happens in a turbine. You have fire, they burn up the parts. And if I burn up the parts too quickly, I actually then have to shift my maintenance schedule. Maintenance schedules are planned out 3 years in advance. If I burn it up right now, it might be 2 years from now. 2 years from now, I may not have a backup turbine, so I lose a lot of money. So we can give them a view with this Lean+Digital. When should you actually overfire to make more revenue without damaging your maintenance cycle? So we use it for productivity, quicker time to value, as well as less cost, as well as how to generate more revenue without risk to your business. So we use it in a variety of ways that way. That's just one example.
Thank you for that, Dr. Parris. And if you're in the audience and have questions for Dr. Parris or his team, feel free to leverage the hashtag you see on the screen. And with that, this concludes the program. Thank you so much. I look forward to have you back perhaps for the Industrial Metaverse Day.
Yes, Lucian, it'll be my delight to join you, and thank you for having me. It's been an honor, but let me also thank you. I love what IoT World does, because I think all of these things have to be digitized and instrumented, and you guys are driving that, and I need that for this energy transmission. So we'll work together as partners.
Look forward.
See you at Metaverse Day.
Much appreciated. Thank you.